so now that we know a lovely formula for the slope of a tangent line to a polar curve, we're going to have to use it. So we're going to find the slope of the line that's tangent to the polar curve. I don't particularly like how I wrote this, so I'm sorry, but the polar curve is right here. So there's the polar curve, right? So that is equal to f of theta. So f of theta is equal to 4 plus sine theta. That's what r is. At the points 4, 0 and the point 3, 3 pi over 2. So we're going to have to do it in two different spots. All right, so and we're going to draw the curve, which I've actually drawn the curve already because, you know, Desmos does it beautifully, but we can draw the tangent lines. All right, so let's start with reminding ourselves of the formula for the slope. The slope is dy dx, which is dy d theta dx d theta, or divided by dx d theta, which is f prime of theta sine of theta plus f of theta cosine of theta over f prime of theta cosine of theta minus f of theta sine of theta. That is the formula. Okay, so let's use it. I need to figure out a couple things. If r is equal to f of theta, which is 4 plus sine of theta, it wouldn't hurt me to kind of figure out for myself just a little bit what f prime is, right? Because I'm going to use that in the formula. So f prime of theta, which is the derivative of this. Well, the derivative of 4 is 0. The derivative of sine is cosine, right? So the derivative is cosine of theta, and we can use that and this in our formula function. So I was going to say in our function. And it is a function. It's a really intense one. It's the derivative of the function. Okay, so m is equal to a big fraction. F prime of theta, that's cosine of theta, times sine of theta, plus f of theta, which is 4 plus sine of theta, times cosine of theta, right? So this is f prime, this is f. Right? And then I got to do it again. Cosine of theta times cosine of theta minus 4 plus sine of theta times sine of theta. Okay, that's the slope. I mean, there it is. But it's not the slope at our particular values. So now we need to look at our points. So let's start with point number 1. Which is 4, 0. And it's implied with how these points are given that that's an r theta value, right? So that's r and that's theta. So over 4 out 0 is right here. So if I call that point 1, right, that's the one I'm talking about. Maybe I should call it A, point A. That way we don't get confused with numbers. So I'm going to call that point A. Okay, and I can see there's a tangent line. Let me grab my handy dandy aquarium ruler and kind of draw the tangent line. There we have it. Right? Okay, so that's lovely, but I need to find the slope of that line. That's what I'm looking for. Okay, so the slope would be, at point A, would be equal to this whole function at that value, right? It'll be dy d theta dx d theta, but at the point 4, 0. All right, so that would be, let me write out this lovely formula. So the important part is the theta is 0. So it'll be cosine, sine, cosine, cosine. And the angle here will be 0, 0, 0, and 0 plus 4 plus sine of 0, 0, times the cosine of 0. over minus 4 plus sine of 0 times the sine of 0. What a mess, right? But the trick is, it's this guy right here. That's my theta. That's what's going in everywhere, right? All right, well, let's see here. Cosine of 0 is 1, and the sine of 0 is 0. So the sine of 0 is key here, because that's going to make a lot of these things go away. So let's see here. The sine of 0 is 0. So that whole thing is 0, right? Because 0 times 1 is 0. The cosine times cosine is 1 times 1. So that's going to be 1. Let's see. This whole thing is going to be 0 because it's all multiplied by sine. So that's going to be 0 there. And then this guy right here is going to be 0. So let's rewrite this. This is equal to 0 plus 4 plus 0 times cosine of 0 is 1 over 1 times 1, right? Cosine of 0 times cosine of 0 minus 0. Okay, so that is 4 divided by 1. That is a slope of 4. That equation, or that line right there, has a slope of 4. Now, they didn't ask for the equation of the line, but I could do it if I knew a Cartesian point for 4, 0, right? But it already is a Cartesian point, right? So let's make a note real quick. They didn't ask for it, but I could do it. Right? The points are one and the same, right? It's still over 4 up 0 in xy, just like it's out to the 4th ring and up 0 angle. So that means that y minus 0 equals m, which is 4, times x minus 4 would be an equation of the line. They didn't technically ask for it, but just in case they do, that's how to find it. Okay, so we answered the question right here. For point A, that's our slope, 4. And then I kind of used it to come up with the equation of a line that was unasked for. All right, let's do it all again, but with point B. Point B gives us an r theta value of 3 pi over 2, which is out to the 3rd ring and down at 3 pi over 2, which is right here. Right, there's point B. So you can kind of imagine how this is going to go, hopefully. It's going to be 0, right? We can see it because it's going to have a horizontal tangent. But let's prove it that our intuition is correct. All right, so for point B, the slope for point B is equal to the derivative, but at the point 3 comma 3 pi over 2. And that's key because that's the theta part. The theta part's the part we really care about. That's r, but we don't care about r so much because r is not used in the formula for the derivative. All right, so this is equal to, once more, because the derivative part hasn't changed. I mean, this is still the formula. I mean, I could box it because that's what we're using. So it's going to be cosine, sine, I'm leaving space for writing the angles, 4 plus sine, cosine, 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 minus 4 plus sine, and then sine. And then literally in every single slot goes 3 pi over 2. Well, just like in the last problem, a lot of those are going to disappear, and because of where 3 pi over 2 is. 3 pi over 2 has a cosine value that's 0, right? Because it's sitting here on this bottom axis right here. So the cosine value is 0. The sine is -1, right? If you're talking about that. So this is 0. So this whole thing will be 0 because 0 times -1 is still 0. This whole thing is 0 because 0 times whatever that is 0. It's 3, by the way, right? This is 0 times 0. You know what 0 times 0 is? Big fat 0. So that's gone. And then this is the part that isn't. That's -1. That's -1. Okay, so this is 0 plus 0, which last time I looked was 0. So 0 plus 0 over 0. And then this is -4 times, this is 3, minus 3 times -1, which would be 0 over 3, which is 0. There's our slope. It is horizontal, just like we thought. Since it's horizontal, the equation actually should be pretty easy. The one issue is that we don't have a point in rectangular coordinates. So we want to make a note. So the point was 3 comma 3 pi over 2. That was equal to an r and a theta. So x is equal to r cosine theta, which would be 3 times the cosine of 3 pi over 2, but the cosine of 3 pi over 2 is 0. So that's 0. And y is equal to r sine of theta, which is 3 times the sine of 3 pi over 2, which is -3. So that means that xy is 0, -3. Now, why do I want that? Well, because if I want the equation, it'd be y minus a -3 equals 0 times x minus 0. In other words, y plus 3 equals 0, which means y equals -3. That's the equation of the line. They didn't ask for it, but it doesn't hurt to find it. What they asked for was the slope, which I found right here, right there. And you'll notice that Desmos backs us up because we have the 2, and of course we know that that is a y equals 3 line. That's horizontal, and it goes right through 0, -3, so that's y equals -3. And then this line right here, there's the tangent point, and the tangent line comes through at 4, 0. There it is. Y equals 4 times x minus 4, just like I said.